Hey there, do you remember the sun's color in your drawings as a kid? It was always a bright yellow like the cartoons you watched. But then, one day your teacher must have told you the sun is white, which confused you because you see orange or yellow in mornings and evenings, although it does appear white at midday. So, you might have asked, why does this dot in the sky play tricks on us? But as you've grown, you learn that the atmosphere makes this optical illusion, and the sun is white because you see the white color everywhere under the sunlight. But you still doubt it because you might have encountered many documentaries or even real pictures from NASA that show the opposite thing. So, what color might the sun be? Stay with us to delve into this captivating mystery. But before we dive in, don't forget to hit that red button, give a thumbs up, and leave a motivating comment. At first, let's take a journey beyond our planet so that nothing stands between the sunlight and us. When we gaze directly at the sun from the vacuum of space, we see a very bright yellowish white spot. In other words, the sun is essentially white with a subtle hint of yellow, but not perfectly white. All stars emit all the colors of the visible spectrum through nuclear fusion. However, the surface temperature of each star causes a certain color to dominate, resulting in the star leaning towards that color. Stars in space are classified according to color and heat, and our sun, with a surface temperature of roughly 5500 Kelvin, falls into the category of G-type stars, often referred to as yellow dwarfs. These stars are of average temperature, and they have yellowish-white color due to the emission of raw yellow light. I bet you have come across this photo many times. It's a real picture of the sun from space, but it's taken in the UV spectrum. This is how the sun looks to the human eye. So we can conclude that both statements of the sun being yellow or white can be correct depending on the context. Now, let's head back to Earth after discovering the sun's true color, and shift our focus to the next question: why does the sun's color change throughout the day? And the answer can be summarized in two words: it's relay scattering, a phenomenon named after the person who sought to understand why the sky is blue on Earth. As you know, our atmosphere mainly consists of oxygen and nitrogen molecules. These particles are much smaller than the wavelength of the visible spectrum, which contributes to relay scattering, which states that the smaller the wavelength of light, the more effectively it gets scattered. Blue light has the smallest wavelength among visible light, which causes it to scatter more effectively, making the sky blue during the day. At midday, a smaller amount of blue light is scattered. Due to this short distance, the sunlight travels through the atmosphere, which doesn't affect the white color of the sun that much. But it gets intriguing when the sun rises or sets. At this moment, the sunlight has to cross a larger distance before it hits the surface, leading to the blue light being completely scattered with some green light, and creating the breathtaking view you see twice a day, with a shiny orange ball above the horizon. In conclusion, we embarked on a journey to delve into the mystery of the sun's color, and we discovered that the sun is white with a subtle yellow hue. We explored how it plays tricks on our vision due to relay scattering, painted the sky blue, and created that romantic canvas during sunrise and sunset. I hope you enjoyed the video and learned something new about the great lamp of our days. If so, please don't hesitate to give me a thumbs up motivating me for more. And don't forget to join the autism community by subscribing to our channel and hitting the bell to dive with us into the ocean of mysteries in our world.